Yes, hello friends. So this is the video editorial for today's GFG problem today, which is rows with maximum. So even if we solve this way with an n square solution, we'll also discuss a better n log n solution and see in how you can implement it. Okay. So yeah, the question says you are given a 2D binary array ARR consisting of only ones and zero. Each row of the array is sorted. So this is interesting, and this allows us to solve it in n log n time. So you're given a binary 2D array, and it is sorted that each row is sorted in non-decreasing order. So we can see here that each row would be having first zeros and then ones because it is sorted in increasing order. Here also zeros and then ones. This makes sense. Your task is to find and return the index of the first row that contains the maximum number of ones. If no such row exists, return -1. So here we can see this row has 3 ones, this row has 2 ones, this row has 4 ones, and this row has 0 ones, right? So the maximum number of rows, maximum number of ones in any rows is 4. So that is this, and this would be 0, 1, 2. So this is second indexed row. So that's why the answer is 2 here. Hopefully this makes sense. And yeah, this is a bit weird of a statement because it says if no such row exists, return -1. I thought like, okay, any row would have at least like 0 ones, either it could be 0. So in that case we should return 0, but it says that like for this case, that if none of the rows have basically ones, so the maximum number of ones is 0, then we should return -1. Okay, that's fine. And the constraint is that n and m, the n being the number of rows and m being the number of columns, is 10 raised to the power 3. So yeah, like if you implement this, so we know that, okay, one second, we know n and m both are less than 10 raised to the power 3. So we can just do an nm traversal or a traversal over for each row, find the count 1 being the count of ones in the first row, count 2 being the number of, or rather we use 0 based indexing, count 0, count 1, count 2. So these are all number of ones in row, right? And then we can find the maximum of this count, and for which of these maximum the first time we saw that maximum we can do this. What would be the time complexity of it? Nm. Basically, see, what was the array? It was 0 triple 1. Okay, let me make a test case for 0 triple 1, 0 1 1, 0 1 1 0, and let's say 4 times this test case, and then finally this. Right, so what I'm basically saying is we'll traverse over all the rows. So first this row, we'll calculate the count of ones in this row. That would be 3, and currently our count of ones is 0, right? We haven't seen anything, and our index. So we have to maintain 2 things. First is the maximum number of ones we have seen, and then the index of that row basically that we have seen. So index initially would be -1 because if all of the rows were 0, like this test case 0 0, then we would return -1. And we'll go over all the rows. We'll check, okay, this row has 0 zeros, this row has 0 zeros, and that's why we'll have to return -1. Okay, hopefully this makes sense. Yeah. So first we'll go over this. We'll see 3 is greater than the current count, so we'll change index to 0 and change count to 3. Then we'll go over this. Our count is 2, so we'll not update it because count is greater than the number of 2's in this row. So we'll go to this. Now see, count is equal to it, it's not greater, but we want the first index. So first index is 0, it won't be 2. So we'll not update here, but for this we will update because it has 4 ones, right? This has 4 ones, so then we'll have to change count to 4 and change the index to 0 1 2 3, right? And this would be a final answer 3. Okay, so as we said, if we actually get the count of each rows, if we actually do a traversal of the row, well, our time complexity would be n into m. This is fine because see, n is 10 to the power 3, n is 10 to the m to the n and m are both less than 10 to the power 3, so this would be less than 10 to the power 6, and that is fine. If you want a cheat sheet, you can do that number of computations. Here there's a number of computations only, right? Should be around 10 to the power 8 to 10 to the power 9, and it is very less than this, like it is 1% of this basically. So this is fine, but we can optimize this even further, and that is what I said in the starting. We can actually use an n log n solution, and this, how are we optimizing it? See, we'll go over each row, but rather than actually traversing the full row, we'll actually use the fact that each row is sorted. So actually the row cannot be like this. It has to be like this because all the rows are sorted. So okay. So if all the rows will be sorted, what we can use is binary search here. Why binary search? Because see, binary search, we can search for the first one, right? If let's say this is our array and we want to get the number of ones in the array, we know the fact that okay, we traverse it and basically maintain a frequency of 1. That is one way, but the better way obviously is to just binary search on the first one. So that can be done using the lower bound function. And as we know that after the 1, every element after it has to be 1 because the array is sorted. So just we'll find the lower bound of it. Let's say the lower bound is this index, so that is 0, 1, 2, 3, 4, and we'll just do the size n minus the first index of 1, right? And how we can find this is there is a C++ inbuilt function lower bound. If you do not know how to implement binary search, if you are a really beginner, you can use this. Like so this like function you should try to implement. If you are a beginner, try to implement binary search on your own. I'm not going to tell you what binary search is and how do you implement it. That would make this video very large. Let me just show you my code itself. Okay, so yeah, in this function, as I said, we'll go over each of the rows. So we are going over all the rows. I'm maintaining two things. Answer, this is the maximum number of ones we have seen till now, and index, this is the index in which we saw the maximum number of ones. So for each row, I'm just calculating the number of ones in the array, and how we are doing it is basically, as I said, we'll just so actually the lower bound does not return the index of it. So if there are two ways to it, so one way is that we can use indexes. So so how you can convert this back to indexes? See, this will give you some this will give you an iterator over the array, and then you can minus that iterator basically into from the beginning of the array, and this would actually give you the index of it. So and then you have to do this. So this is one way to implement it. Basically what I say mean is, see, for this array only, rather the lower bound function does not deal with actual indexes. It deals with iterators. You can think of it like pointers. If you do not know, I think you should know what iterators are, but you can think of it in based on pointers. And because it's an array, so the key property of array is that all the blocks are assigned continuously, right? If for map, or if for a map, if you think about it, map are not assigned continuously. So an iterator over a map is, so if let's say you have an iterator of a map and you want the distance between the beginning of the map to this iterator, let's say the iterator is it, how much time complexity will it take? If you don't know this, because map does not assign memory continuously, so the iterator has to go from the beginning, then to the next, then to the next, till it reaches it, and that would take linear time. But because arrays are assigned continuously, that's why you can do this function, the minus function basically, and that's in constant time. So if let's say you have this, because this is a constant memory, and you know, like if it's an int, it would be a 4-byte thing. So you just calculate the total distance between in the memory between this, and divided by one cell's distance, basically being if it is a vector of int or long. I think I'm over explaining it, but yeah, just a cheat sheet thing, that because we are doing lower bounds on an array, we can do this minus thing and converting it to index, and that is a constant time operation. So one way is that you change this back from iterators to index. The other way is that you could just deal with iterators only. So this will return an iterator over the array, and we just minus it from the end iterator. So the end iterator is the like, see, it's similar to array, that if let's say this is 0, 1, 2, 3, 4, right? So 5 is after the last element of the array, like the 5th index, or we can say the size of the array. Similarly, the end iterator is after the last element, so it's actually not in the array, and the beginning is actually in the array. Like, I'm going over very basic things now. Yeah, this is fine. This will give you the count of ones. If you are a beginner, do not use this function. Try to implement it on your own. And yeah, I get for each row I get the number of ones. If it is greater than answer, I change answer to ones, and I update my index also. And finally we can return index. Yeah, this works. Thank you for watching. If you were able to understand anything, and yeah, if you like the video, give me a like and subscribe, all of those things. Bye bye.